All right, so this is evaluation continued. I think it cut out last time, just in case. I've also provided this recording here, so you can see both in case. The next one we have to do is practicing with an exponential and a polynomial. So we just did an exponential and a sine function. Now we'll see what our equation would look like if we had a polynomial instead. So here our equation is y prime prime minus 4y prime plus 4y equals 7e to the 2t plus 3t squared plus 10. Y'all both have that down? Or?
Yes.
Okay, great. So here it's not going to be three separate yp primes. This is an exercise in like trying to figure out how to split up your y sub p's. So if you look, we have two different types of equations, I guess is a better way to put it, or two different types of functions on the right side. We have an exponential, so we have 7e to the 2t, and then we have our polynomial 3t squared plus 10. You should think of 3t squared plus 10 as one function, right? So it's not necessarily for every term you have a y sub p, for every function you have a y sub p. Okay? So let's just start with our formula, right? So y equals y sub h plus yp1 plus yp2, and we'll see how we split up yp2 differently, considering that the polynomial is missing a term. Do you follow what I'm saying, or okay, good. So yeah, let's just start with y sub h.
Okay.
So we have 4y prime plus 4. Okay, so what did y'all get for your y sub h?
That's my God.
Did y'all get?
I think I did. You plus. Oh, okay. That's what I was.
Did you get like an imaginary number? I think
Yeah.
you said it on the screen.
Okay. Now I got it. I was confused.
Okay, great. Yeah, so as we can see, this is a case where our r or lambda value, whatever you use, it's the same number again, it's just squared. So we have c1t e to the 2t plus c2 e to the 2t, given our like formula that we learned way back. Now we're going to solve for yp1. And here, yp1 is e to the 2t. Do y'all see something special about this e to the 2t? Or about this right-hand side?
Does it, since it has two.
Nope. So if you look here, our exponential of our e here is 2 to the t. And in a similar vein, the exponential of our e in the right side is e to the 2t. So we're going to need to change this term or change our guess, because if we had just like if we have our guess like g u e s s a sorry, oops, that should be y p1 equal to a e to the 17 a e to the 2t. We're gonna get an error because it matches the same exponent here. A good way to explain it is let's say I have this homogeneous equation like c2 e to the 2t, right? So if I have like c2 e to the 2t for my homogeneous, right? And I have ae to the 2t for my particular, the coefficient of e to the 2t is c2 plus a. So we don't know what c2 is, right? We just know that it's some constant that we determine, right? So we can't use this. So what we have to do is we have to multiply our guess by t. I don't know if y'all remember that from 2 weeks ago, but Francesca, do you remember that? Or yeah, so we have to multiply our guess by t. The issue is that we have another t to the et, so we have to multiply it by t again. Does that make sense? So, oh, go ahead.
You take into account your YH when you're doing your YP?
Yes. So
Okay.
any other exponent for our e, right? Like 3, 4, -7, 8, it would just be a e to the 2t. But because our our y sub h has an e to the 2t in it, we can't let them have the same form.
Okay.
So you multiply your guess by t until you get it right.
That's what he's trying to explain to us. Oh, okay. See, that was that was in the homework too. I was really confused about that.
Does that make sense?
Yeah,
Like
yeah.
it's one of those things where it's like you trust them, like the method of the madness, right? It's very complicated to understand theoretically. Just think like if you even if you solve equation and you get a wrong guess, just think your first gut reaction should be, okay, I'll multiply my guess by t.
Okay. So no matter what you do, your YH and your YP, they shouldn't really be able to mesh together.
They shouldn't have the same exponent of e.
Okay.
That's a really specific criteria.
Okay.
Say it was like the YH was just like T e to the 3T and your YP was e to the 2T, you wouldn't have to do that.
You would,
You would still have to multiply
because
by T.
you would still have one term that is e to the 2t. Does that make sense? So if this was e to the, oh crap. So if this was e to the 3t, right?
Yes.
And this was e to the 2t,
Oh, well, hypothetically, if they were both e to the 3T.
then yeah, it would just be a e to the 2t.
Okay.
Does that make sense?
Yes.
But for any term that shares the same exponent, it can't be the same as y sub h.
Got
Because
But if they were different, then
It's
YP
normal.
could be.
yeah, absolutely.
Okay.
So if y'all remember from up here, we had our two exponents were -2t and 4t, and our guess was a to the et, right? And it was just a singular a to the et. No, not t a to the et, right?
Yeah. But what if it was what if your guess was A E to the 4T?
Then we would multiply it to be at to the 4t.
Oh, okay.
At times e to the 4t.
That makes sense.
I remember the general rule. I think he went over that, right? Or maybe he didn't explain it well, but the general rule is that if it's the same exponent as your homogeneous solution, you multiply it by t.
Okay.
Good?
Okay. Yeah.
Okay. So here, instead of ae to the 2t, we multiply it by t, we'll see that we'll get at e to the 2t. We see that still matches. We multiply by t again. So we end up getting a t squared e to the 2t. And unfortunately, this is going to make our derivative a pain in the butt. So,
We don't have to solve.
in the interest of time, we won't have time to solve it because our session time is limited. So I'm just going to give y'all what the derivative would look like, and y'all can follow in the session notes that I'll give y'all how y'all could have derived this. But there's a very clear pattern that I'm sure y'all will see. And hopefully y'all will be able to see that in my recording as well. Um, so now from here, we know that we have to plug this into our original equation.
T, 8, 8AT.
Oh yeah, I'm so sorry, my bad. And if we plug that in, so we would have gotten. So let's plug it in now. We get 2a e to the 2t 8at e to the 2t plus 4at squared e to the 2t minus, it's long, minus. Okay, so y'all should have gotten 2a e to the 2t plus 8at e to the 2t plus 4at squared e to the 2t, which is our y prime prime, right? Minus 8at e to the 2t minus 8at squared e to the 2t, which is our negative 4 times our y prime prime. Or sorry, negative 4 times our y prime. And then plus 4at squared e to the 2t, which is our 4y, equals 7e to the 2t. Good?
Yes.
Great. And then we'll see we have two things cancel out. So we have two terms of 8at to the e to the 2t. One is positive, one is negative. Those will cancel. And then we have another term, negative 4at squared e to the 2t. And, we have two terms of 4at squared e to the 2t, right? And then one term of negative 8at squared e to the 2t. So that also cancels out.
Yeah. If they didn't cancel out,
Then your guess was wrong. So this is
Oh,
actually
okay,
this
my
is
guess is
actually
wrong.
this is important. The exact way in which it like crosses uh, the exact way in which it cancels shows that you've done your guess right. Because if you look, you'll see that all the terms that canceled were our t times e to the 2t or t squared times e to the 2t. We want to be left with our original a e to the 2t and then 7e to the 2t. Otherwise, how would we solve for a, right?
Yeah, exactly.
Because we would get like at e to the 2t is equal to 0, so a is 0, but at the same time, a is 7 half. So you want it to cancel, which shows that our guess was right.
Okay, perfect.
So it also helps to, like, it'll check your work for you, which is good.
Yeah.
And I'm sure y'all can see that, like, a here is just 7 half, right?
Yeah.
Perfect. And that's our YP1. That was a lot, but YP1 is equal to 7 half t squared e to the 2t. Now we have YP2. So here we have a polynomial. Remember with polynomials, you can't miss a term. You have to have everything as the same term, I guess. Does that make sense?
Yeah.
So we know that what do you think our guess is going to be?
AT squared plus BT plus C.
Perfect. And then this is super easy to derive. So let's just do that quickly. So what did you get for your YP2 prime, Francesca, and your YP2 prime prime?
I got 2
Perfect. And then let's just plug in. And then here, our right side of the equation is going to be set to what, Leslie?
3t squared plus 2.
Perfect. And then we'll just solve for A and B. So what did y'all get for your systems of equations?
4a equals 3, 4b minus 8a equals 0, 4c minus 4b plus 2a equals 10.
Perfect. And we can just solve. So if 4a is equal to 3, negative 4a is going to be what? Negative 6. So 4a is equal to 3, right? So negative 4a is negative 3. So negative 8a is negative 6. And then you can just plug that in into our second equation. Does that make sense? Okay.
Wait, so a is 3 over 4?
Yeah.
Right, okay, so 4a is equal to 3, right?
Yes.
Yeah.
So if 4a is equal to 3, 8a is equal to what? Multiply both by 2.
Yeah.
6. So what if 8a is equal to 6, negative 8a is equal to negative 6. So here I'm substituting in negative 8a is equal to negative 6 into our negative 8a.
Oh, okay.
Yes.
Yeah. C is going to 4. C is going to equal 4c is going to equal 7 minus 3 half. So 8c is going to equal 14 minus 3. So 8c is going to be equal to... Oh, whoops, no, I did that wrong.
That'd be plus.
That's read 10. My bad.
So 6 is 16.
That should be 16, and then that should be... So 8c is equal to 32 minus 3. 8c is equal to 29. C is equal to 29 over 8. Okay, great. So now we found our A, B, and C. Our YP2 is equal to what?
3 halves 2 plus 29.
Perfect. I got my hand ready. So bad. 9 over 8. So now we know that y is equal to y sub h plus yp1 plus yp2. what is y sub h? Well, what is our final equation?
It would be 1 e 2t plus c2t e 2t.
Or you can swap them, but same thing. Yeah.
Either one. Plus 7 over 2 t squared e 2t plus 3 over 4 t squared plus 3 over 2 t plus 29 over 8.
Perfect. And that's a long answer, but that's the correct answer. So hopefully that clears up a lot of confusion about second order. Remember your guesses. Remember so I guess the summary. For every function, a separate y of p. And if you have a wrong guess, with like it doesn't cancel out, or something has gone really wonky, multiply it by t.
Okay.
Good?
Yeah, perfect.
Perfect.